Welcome. I'm Rusty Lowe, and I'm one of the scientists on the Globe Observer team, and I work with Globe Mosquito Habitat Mapper. This is a tool where we actually use the app, the mobile app, to identify the aqueous habitats that we find are immature mosquitoes. I'd like to introduce the Globe Mission Mosquito team, who are all here to help you with your IVSS projects.
Greetings, friends and Globe family. I am Dorian Janney, and I'm located in the Washington, D.C. suburbs in Maryland. Please feel free to reach out to me if I can help you access NASA data and help you as you're considering which types of research questions you might like to answer.
Hi everyone, my name is Cassie Sofing and I'm located in South Dakota. I'm here to help you identify potential research projects, and I work with formal and informal educators.
Hi, my name is Liz Burke, and I live here in Kasilof, Alaska. My job with IGS primarily focuses on developing content for both formal and informal education products, such as the Beyond the Bite Disease Guide and our current project, the Mission Mosquito Science Notebook.
To do Globe Observer, all you need to do is download the free mobile app. And when you do so, you're going to join more than 150,000 people around the world, citizen scientists, who are collecting data about changes in the Earth system. You'll be collecting data about clouds, about land cover, about trees, and about mosquitoes. If you haven't used Globe Observer before, but you know the Globe program, it's important for you to know that the tool, the Mosquito Habitat Mapper tool, is actually the GLOBE protocol. It will take you step by step through making your observation, recording your observation, documenting it with a photo, and uploading your data to the GLOBE database. When we use the Mosquito Habitat Mapper, we're trying to find those crazy places, sometimes cryptic places, where mosquito moms lay their eggs. Here you've got some citizen scientists here looking at an abandoned watering can. Once you get your that observation, you also have the option, if you want, to take a sample and actually identify the mosquitoes. And if you want to do that, we have an in-app key that you can use. But this is optional. If you do this, you need to have a couple extra pieces of equipment, a very inexpensive clip-on microscope for your mobile device, some toothpicks, and a plate is really all you need. You may not be wanting to go out and roam around and collect mosquito sites right now in this climate, but students in classrooms can actually do a project by staying close. They can build a trap using a 2-liter pop bottle, just using materials that they have at home, take that trap that they make, put it outside their door, and you suddenly have a group class project that everybody can participate in without coming together. What's important for us to communicate today is that there's a change this year for IVSS, which is accommodating the current conditions, and you can actually put in a IVSS project that's just using data this year. You don't have to collect data. And so I'm wanting to offer to you the opportunity to use the Globe Mosquito Habitat Mapper data. We have about, here there's about 24,000. We have now about 26,000 observations around the world. You can see that we have some hot spots. All these hot spots are ripe for analysis. And there's a lot of different questions that you can ask, and I've put just a few of them here. I'm sure you can think of many more. I just wanted to show you what you can do with the deep dive. What I did is I went to Advanced Data Access Tool on globe.gov. You can find that in the data section of the GLOBE program website. And what I did was I collected data and brought it into a spreadsheet. I looked at a specific place, Dakar, Senegal, and tried to see if there were any patterns. And sure enough, I'm seeing that, the different kinds of water sources that citizen scientists have identified vary widely. And there is something to be said there that we can maybe look at patterns and try to see what we're seeing. We also see that there is also an unequal distribution of the different genera of mosquitoes that were found. So maybe there's a pattern between the places that they're finding mosquitoes and the kinds that they're finding. There's all kinds of different kinds of questions. So download the data, look at it, look at patterns, form hypotheses, and then the next step is you want to compare your Mosquito Habitat Mapper data with other sources of data. You could use NASA satellite data, you could use GLOBE data, you could even use GLOBE observer data. And for mosquitoes, you might even be able to use mosquito data that's been collected locally in that region, or even disease data that's reported from that area. So I wanted to point out that on the GLOBE site, there is something called the GLOBE Mosquito Protocol Bundle. This was put together by the Science Working Group. And what it does is identifies all the other sources of GLOBE data that you can use in your analysis of the mosquito habitat mapper data. I wanted to just point out, most of you familiar with the atmosphere, biosphere, hydrology, and pedosphere protocols, but also remember you can also use GLOBE observer data in your analysis. And this is one thing that our team is trying to actually promote, is collecting coincident data using 2 or more of the tools on the GLOBE Observer app. So you'll see here that in this example, there's a new mosquito observation. They found the citizen scientist has found a ditch, and then they are going to pair this data by also collecting land cover data or tree data, because this provides a context to understand where are these mosquitoes found, why are they found, how do they co-vary with the landscape. And then if you want to go further, you can say, how do these things co-vary with respect to environmental conditions that might be obtained remotely using satellites. We have something called the Science Cafe. This is our scientist blog for GLOBE Observer. We have a bunch of students who have actually been guest scientists this summer. They're all high school students from around the country. And here are some of the cool ideas that they've had for projects. You can take a look at these and maybe come up with your own. And lastly, I wanted to point out that an area that I've been a IVSS judge for many years because of my position as a member of the GLOBE International Scientist Network. And I have not seen any projects so far that actually are done by students that have an interest in computer science and want to do some coding. But this summer, we had several students that were interested in developing Python code, creating Jupyter notebooks. And so what we did is we let them do whatever they wanted for their projects. And here are a couple examples of projects by our high school students. So if you have students that are interested in creating code, we can upload it we have a library for code for Mosquito Habitat Mapper now that can be used for the analysis of data. So that's something I'd really like to encourage, and take a look at some of these projects to see what they're like. Our team, which you met earlier, we're all here to help you. We have a lot of different resources that can help people who are running informal science programs or teachers working in classrooms to help prepare the students with the background that they need to do a mosquito project. So take a look at some of these resources. And I also want to let you know that all the steps you need to do any mosquito habitat observations, it's pretty straightforward. You can do it with our app, but we also have a playlist of short videos that you can use to in training citizen scientists and training students to use the Mosquito Habitat Mapper protocol. And I wish you lots of luck in your IVSS projects. And I'm speaking for our whole team when I say we can't wait to see some projects that look at mosquitoes.